All right. So the past couple days we've been practicing factoring and solving by factoring and working with those equations. And today, what we're going to look at is bringing in the geometry. So nothing we do today is really new. The geometry ideas that we talk about are all going to be from chapter 1. We've been doing them since the start of the year. The solving equations stuff is not new either. We've been doing it all this entire past week. So we're just taking the algebra skills we've been working on over the past week and putting it into some of the geometry ideas that you should already be familiar with. That's what we're doing. And these problems are going to get a bit heavy on the work, but the ideas are, we have looked at them separately, so now we're going to put them together so that when we get to new geometry ideas that involve these harder equations, then you've seen what to do with them and how they work before. So first off, here is the important part of today. All right, if you get nothing else out of today, this is the most important thing. When solving these equations, the answers for x can be negative. And this is not a new thing. This is something that has come up in some questions in the past. Sometimes on occasion I'll get asked, I got a negative answer, is that okay? And the answer is, well, it might be. It might be okay to get a negative answer out for x. What cannot happen is for the measurements to be negative. The measurements being negative was what causes a problem. So if you plug that answer back in for x, which we've done before, that's not new. If you plug that answer back in for x and the measurement comes out to be negative, then we have a problem. Then we have an issue. We cannot have a negative measurement. We don't have negative angle measures, negative side lengths, negative distances. Those should all be positive. So what you need to check for is when you plug it back in for x, are the measurements positive or negative? That's what you should be checking for. So as we go through these problems, keep an eye on that. That when we solve the equation, get our answer out for x, we're going to plug them back in. And what we are looking for is the measurements to be positive. As soon as we have a measurement that's negative, the answer doesn't work. So let's take a look at the first one. I'm going to give you about 30 seconds and see if you can come up with an equation here. I've given you the hint that we should be adding two things together to get something. This is the very first idea that we talked about in geometry, which is segment addition postulate. Segment addition, pieces add together to get the whole thing. And the way that I usually like to organize these equations is to start with the total. Start with the entire distance, which is the 6x squared minus 12. I know that that's the total. I know that that's what it's going to add to. So I'm going to put that on the right side. And then my other two pieces are going to go on the left side. So those are my pieces adding together to get the entire segment. Oh, 16x. Thank you. I just had a blind spot somehow. All right. So now we're going to solve this equation. First thing I want to do is I want to combine together any pieces on the left and right side that can be combined together. And all I have is on the left side, I have a 16x here and a 4x here to be a 20x. Minus 2x squared equals 6x squared minus 12. So we're combining together our like terms. Then, if you remember how we talked about solving these equations yesterday, we said we want to get everything on the same side so that it's set equal to 0. We want to make sure that everything's set equal to 0. So the way that I always make things easier for myself is that I want my x squared term to be positive. So I'm going to pick the side that has the bigger x squared, and I'm going to move everything to that side. I'm going to pick the side that has the bigger x squared on it, and everything's going to go to that side. So here I have a negative 2x squared and a positive 6x squared. Well, positive 6 wins, so everything moves to the right side. Anything on the left side, get it out of here. The 20x, go away. Subtract it, move it to the other side. The negative 2x squared, get it out of here. Add it. So that on this left side, all I'm left with is 0. So that the entire thing is set equal to 0. Remember, the whole idea of solving this equation, of how to solve this equation, only works with 0. That's why we're getting it set equal to 0. Oh, and plus 2x squared here. 6x squared and 2x squared is 8x squared. Then I have a minus 20x. Then I have a minus 12. I had some people that had trouble with this when they were trying some examples. Make sure, before you start your factoring, make sure that it's written in that order. X squared first, then your x, then your constant, then your number. So I'm putting my 8x squared first, and then my minus 20x, and then my minus 12. That's called standard form. It's in order of the x squared, then the x, then the constant. So now I can start my factoring by taking out a GCF, which is, what number can I take out of all of these? It's a 4. I can't take an 8 out because the 20 and the 12 aren't divisible by 8, but I can take out a 4. That's 2x squared. Minus 20 divided by 4 is 5x. Minus 12 divided by 4 is 3. And so now we're going to factor this. This is the only one I'll show out the details of the factoring here today. So we're going to multiply our outside terms. 2 times a negative 3 is a negative 6. I'm looking for two numbers that multiply to be a negative 6 and add to be, what's my middle number? Negative 5. Make sure the signs come with it here. So I want one positive, one negative. And since I'm adding to be a negative 5, the negative needs to outweigh the positive. It's going to be 1 and 6. Or rather, 1 and negative 6. So don't lose your 4. First term is still the first term. The last term is still the last term. But instead of my middle term of minus 5x, I'm instead going to put plus 1x minus 6x. I'm going to make sure not to lose my 4. In my first group, is there a number that can come out? No, there's not. It would just be a 1. Is there an x in both of them? Yes, there is, so I can take an x out. When I do that, I'm left with the 2x, one of the x's went away, plus 1, one of the x's went away. Minus is the first sign I see, so minus is the first thing I'm going to write. And what number can come out of both of them? 3. Is there an x in both of them? No, there's not, so I can't take it out. So we have 6 divided by 3 is 2x. Took a negative out means that I'm going to change that sign to a plus 1. And we have, ding, ding, my 2x plus 1's match, so I can take them out. Don't lose my 4. And I can take that 2x plus 1 out of the whole thing. When I do that, in my first group, I'm left with x. My second group, I'm left with a minus 3. So that is my factoring. So now to solve, remember the idea behind solving these, we talked about this last time, is that we have a thing times a thing times a thing is 0, which means that one of them's got to be 0. That's the only way I can multiply things together and get an answer of 0. So a thing times a thing times a thing is 0. So one of them's got to be 0. Either 4 is 0. Well, 4 is not 0. Or 2x plus 1 is 0. Or x minus 3 is 0. So let's solve each of these separately. If the 2x plus 1 is 0, I want to subtract 1 from both sides to get rid of the adding. Then I want to divide by 2 on both sides to get rid of the multiplying. So x is negative 1/2. Over here, if x minus 3 is 0, well, I want to add 3 to get rid of the subtracting. So I get x to be 3. So there's my 2 answers. Now, we're not quite done yet, but I'll pause here. Do we have any questions on the solving? All right. So now our last step. Remember, this is the important part of today. Remember that it doesn't matter whether my answers for x are negative. It matters what the measurements are. If any measurements are negative, that's when I know it's not going to work. So we're going to start with if x equals negative 1/2. Well, if x is negative 1/2, I'm going to start with the one that's the easiest to plug in. Let's plug it into b to c. B to c equals 4 times x is negative 1/2. 4 times negative 1/2 is negative 2, which is a negative measurement. Not going to work. So my negative 1/2, not a valid answer. So now we need to test our positive 3 if x is 3. If x is 3, now we need to figure out our measurements. Let's start with b to c again. 4 times x is 3, which is 12. That one's fine. Let's check a to b. 16 times x is 3 minus 2 times 3 squared. That is 48 minus 18, which is 30. Still positive measurement. And a to c, we have 6 times x is 3 squared minus 12. So that is 9 times 6 is 54 minus 12 is 42. Measurement is positive, positive, positive. And that answer works. So to find the measurement of A to C that we're looking for, what did we get? Well, we got 42. So that is our final measurement. This is the exact same idea, but for angles. Again, this is an equation that I could have asked you to set up in chapter 1, which is that the pieces of the angle have to add to the whole thing. Once again, I'm going to start with the entire angle and put it on the right side so that I know this is the total. And then I have my pieces. We have a 2x squared minus 4x plus 34. And then we have an x squared minus 9x plus 30. So we're going to put all of our terms together. Group my x squared terms together on this left side here. I'm going to leave the right side alone for now. I'm going to keep it as the 106 plus 2x. We'll move that around in just a minute. But over on this side, I can combine some things together. I have a 2x squared and an x squared to be 3x squared. We have a negative 4x minus 9x is a negative 13x. And then we have a 34 and a 30 is 64. And now we're going to get this set equal to 0. Remember, I always bring it to the side that has the largest x squared. Well, this one wins because left side wins because the right side doesn't even have an x squared. So we're going to move everything to the left. Everything's going to go to the left. So this 106, move it over the left side. This 2x, subtract it away so that it goes over to the left side. We're kicking everything out of this right side so that I get 0. And on the left side, that gives me the 3x squared. Negative 13 minus 2 is negative 15x minus 42. Remember, you want to start by factoring out a GCF number that can come out of the whole thing. All these are divisible by 3. So I can take 3 out of the whole thing. Then I'm left with x squared minus 5x minus 14. So that makes the numbers a lot easier to work with. Now I'm going to pause here and let you try factoring it yourself. Negative 2, positive 7. Should be our two answers. Okay. Remember that it doesn't matter. This is the important thing. If you're getting nothing else from today, this is the important part. It doesn't matter about the answers for x and whether they're negative. It matters about the measurements and whether you get negative measurements. So that's why we're going to plug both of these back in and see if they work. We plugged in negative 2 to all these measurements and got the measurements out. We plugged in 7 into all these measurements and got the measurements out. And you'll notice what happened both times is that all of our measurements got to be positive. So negative 2 is an answer that works, and 7 is an answer that works. Both of them work. So we should use both answers. Because when I plugged those in, the measurements came out positive. Not only that, but you can see the initial equation I set up, the geometry idea, also working here. We have 50 and 52 adding to 102, the pieces adding to be the whole thing. We have 104 and 16 adding to be 120. Pieces adding to be the whole thing. So to answer the question of what's the measure of angle ABP, well, if x was -2, then we would say that the measure of angle ABP was 50 degrees. Or if x were 7, if we wanted to use that answer, we would have 104. So 2 possibilities for that angle measure. And that's my final answer there. So we have x squared plus 10, and then we have 4x plus 5. And what is true about those? Here comes the geometry. What is true about those? What is true about these two angles? They add up to what? 180. And we had a name for those. Anyone remember the name of those? Linear pair is the name of them. Pair of angles that make a straight line. So I take these measurements, add them together, I get 180. There's my equation. Again, combine your terms together. Here's all my x squared terms. Here's all my x terms. And then my number terms, my constant terms, I have a 10 here and a 5 here to be 15. And then remember that we need to set it equal to 0 first, because otherwise the factoring thing is not going to work. So we got to set it equal to 0 next, and then factor and solve. And I will show answer to that tomorrow.